Drawing this graph is the same as any other. We need to know what crosses the axes. So when x is 0, y is 2, and y is 0, the modulus of x plus 2 is 0. That means that x is minus 2. So our graph will be y equals x plus 2. And y equals x plus 2, and this portion of the graph is y equals minus x minus 2. So y equals e to the x plus 2. Anything to the power x has this shape with the x-axis. As an asymptote gets closer and closer to it, we're now shifting everything up by 2, which means it's going to cut at 3, and we have a line at 2 where the graph gets closer and closer to but never touches. Y equals the modulus of log x. So we're going to start by sketching log x. And then if we have the modulus, then our graph will look like this. Before we can write this as a partial fraction, we have to recognise it as an improper fraction. We have a cube and a cube, so we're going to have to divide. So we want to divide x cubed minus x squared into x cubed plus 1. If we multiply by 1 and then subtract, we get the x cubed plus 1 all over x cubed minus x squared equals 1 plus x squared plus 1, and I'm just factorising the denominator. I'm going to take the fraction and say that would have come from a over x squared plus b over x plus c over x minus 1. If I multiply through by the denominator, we get that x squared plus 1 equals a times x minus 1 plus bx times x minus 1 plus cx squared. So if I start by letting x equal 0, on the left hand side I have 1, and on the right I have minus a, so a would be minus 1. If I let x equal 1, on the left I have 2, and on the right I have c, so c is 2, and then we pick any other value, so we'll let x equal 2. On the left that gives us 4 plus 1, which is 5, a plus 2b plus 4c. So 5 has to equal minus 1 plus 2b plus 8, which gives us that 2b is minus 2 and b is minus 1. So our complete partial fraction is the 1 from the original division, minus 1 over x squared minus 1 over x plus 2 over x minus 1.